The impossible floating ring experiment, defying physics with eddy currents. What if I told you could make a metal ring float in midair? No strings, no magnets, no tricks. Even crazier, what if that floating ring could spin wildly while suspended in empty space? Today we're going to perform what looks like an impossible magic trick, but it's 100% real physics. This experiment reveals a bizarre phenomenon that powers everything from roller coasters to bullet trains. Let's uncover the secrets of eddy currents and magnetic braking. Introduction to the science. When most people think about magnets, they picture simple attraction and repulsion. But when you combine magnets with moving conductors, something extraordinary happens. Invisible whirlpools of electricity called eddy currents form. These swirling currents create their own magnetic fields, which can push back against the original magnet with incredible force. This isn't just a lab curiosity. This effect is why high-speed trains float above their tracks and why roller coasters stop smoothly without physical brakes. Today, we'll recreate this phenomenon in a way you've probably never seen before. Step-by-step experiment. Here's how to build this mesmerizing demonstration. 1. Materials needed. A strong neodymium magnet, ring shape works best. A conductive metal ring, aluminum or copper, and a non-magnetic stand like a plastic rod. 2. Set up the magnet. Mount the ring magnet on the stand so its north pole faces upward. 3. The magic moment. Drop the metal ring onto the magnet, but instead of hitting it, the ring floats mid-air, wobbling like it's defying gravity. 4. Kick it up a notch. Spin the metal ring before dropping it. Now, it doesn't just float, it levitates and spins for seconds before slowly settling. The physics behind it. Here's why this happens. 1. Eddy currents form. When the metal ring approaches the magnet, the changing magnetic field induces circular electric currents inside the metal. Faraday's law. 2. Lenz's law strikes back. These eddy currents generate their own magnetic field, which opposes the original magnet's field, like an electromagnetic tug of war. 3. Equilibrium achieved. The repulsion balances gravity, causing the ring to hover. When spinning, the effect is even stronger. The ring acts like a gyroscope, resisting changes to its motion. This is the same principle behind magnetic brakes. In trains, eddy currents slow down cars without friction. In power meters, they measure electricity usage. Even in space, NASA uses eddy currents to stabilize satellites. Surprising observations and applications. Try these twists. Use a slotted metal ring. It won't float well because eddy currents can form complete loops. Heat the ring. Resistance drops, making eddy currents stronger. The ring floats longer. Try different metals. Copper works best. Steel fails. It's magnetic and doesn't form efficient eddy currents. The weirdest part? The faster the ring spins, the longer it levitates. That's why maglev trains need speed to stay afloat. Final conclusion and takeaway. What looks like magic is just physics outsmarting gravity. Eddy currents are everywhere, silently controlling speed, saving energy, and even protecting machinery. Next time you see a roller coaster stop smoothly or a train glided without wheels, you'll know the secret. Invisible whirlpools of electricity pushing back against the world. Try this experiment yourself. Strong magnets are cheap online. And let us know in the comments what other illusions you'd like us to explain. If you enjoyed this mind-bending demo, hit like, subscribe, and we'll keep defying physics together. Thanks for watching.